So now in this problem 54, we have these two vectors, vector A 2, 3, and vector B 8, 12. So now you try to express one vector as a multiple of another vector, and you compare the x components and the y components. You see this guy, 8 is 4 times 2, and also 12 is also equal to the 4 times 3, right? So that means 4 times 8, this is equal to 8, 12, which is just the vector B. So you have the vector B equal to 4 times vector A. This just implies vector B is parallel to vector A. And this is a very simple case, okay, to determine the two vectors are parallel to each other. Now let's look at the 56. We have the two vectors. A is the 2, -4, and B is the 2, 1. So definitely this time neither A or B is a multiple of the other, right? A here has the 2 as the x coordinate, x component, and B also have the has this 2 as the fourth component. So this guy should be the 1 times 2, right? If you have the 1 times -4, you get a -4, not equal to 2, not equal to 1. So first we can see A is not parallel to B. Then let's check if they are perpendicular to each other. So to determine if the two vectors are perpendicular to each other, we just need to compute the dot product of these two vectors. So we have the 2, -4 times 2, 1. And then you have the 2 times 2 plus -4 times 1. So you have the 4 minus 4, which is equal to 0. So that means this A is perpendicular to B. So you have A perpendicular to vector B. Now let's talk about two special position vectors in the rectangular plane. The first one is called the vector I, which is one vector with the unit length on the x-axis. So this guy here, this is I. Another one is the vector on the y-axis with the unit length. It's called the vector J. So we have these two special position vectors. They are called the unit vectors. Okay, actually two special unit vectors. And you can get the length of these two vectors. So they just have the one as their length. Now, let's look at a general vector. Suppose I have the vector v, which is in the component form. Then you can rewrite this vector v as the sum of these two vectors. So actually, these are the horizontal component, and this is the vertical component of this vector v. Right? We just write this vector v as the sum of its horizontal component and the vertical component. And the first guy can be written as the a1 times 1, 0. Second guy can be written as the a2 times 0, 1. Then the first one is just the a1 times I, then the second one is the a2 times j. So any vector v can be written as the linear combination of these two unit vectors. So that is a1 times I plus a2 times j.